So we will discuss about the depth first search in this lecture. This is the another technique of the traversal of the graph. It also has a short form, DFS. So for doing the DFS is usually done on the directed graphs, and not actually being said, but it has more usability in the directed graph. The DFS is not only being done for finding out the traversal or finding out the exploration sequence, but it can be used for finding out the strongly connected components, and it can be used for finding out the topological sort sequence in the activity networks. So the strongly connected components and the activity networks and the topological sort, these are the directed graphs. So the DFS has more usability there in the directed graphs. So suppose there is a directed graph given. We have already formed the adjacency list of this graph. The DFS works like this. Suppose in this graph, first vertex is A. So let us start this vertex as one time. So what we are doing, that we are assigning a time 1 for vertex A, and let's say that when it is starts, we assign a start time to every vertex, and when we are finishing up the job with that vertex, we will finish the finish time. We will set the finish time. So the start time and the finish time. Now here we are starting the vertex number A at time 1, and then see the connection from this A. There are two connections from A, B and D. So out of these two, let us pick the first one, which is B. And let's say we start B at 2 time. Now, without seeing the connection to D, because we have already seen the connection to B and we are going in the depth. So let's go to the depth of B first. So B has a connection A, and A has already got explored at one time. So we will not explore it again. So we see E. Now let us explore this E. So this E will be explored at 3 times. Let us see the connections from E. A has already got explored, so we will not explore it again. J, let's explore J. So J will be explored at 4 times. Now see the connection from J. There is no connection from J. So there is no way we can go to other vertex from J. So what we will have to do, we will have to finish this J. So let's finish J at 5. Now this J was called from E. So let's go back to E. We have seen all the connections from E. So let's finish E also at 6 times. Fine. So if we are starting, we are giving one more time than the previous one. When we are finishing, we are assigning one more time than the previous one. This E was called from this B. So let's see the connections from B. A and E, both of these two we have seen. So we can finish this B. So this will be finished at 7 times. Now B was explored from A. Let's go back to A. We have already seen B from A. Let's see D. So D can be explored at 8 times. So the start time of D is set as 8. So let's see the connection from D. E, it has already got explored. I, yes, there is a possibility of exploring I because it has not got explored earlier. So 9 is the start time assigned to I. Now see the connections from I. It is E, which has already got explored. J, it has already got explored. So we can finish this I because we cannot go any further from I. So 10 is the finish time set to I vertex. Now I was explored from D. So let's see the connections from D. Both the connections from D, E and I, have got explored. So we can now finish this D at 11 times. D was explored from A. See the connection from A, B and D. Both of these have got explored. So we can finish this A. So this A will be finished at 12 time. Now if you see that we cannot go to any other vertex. We were following a sequence. A chain of the vertices were there and we were actually going there. But now we are not finding any link. So if you are not finding any link, then in the alphabetical sequence, whichever vertex comes first is started automatically. So out of C, F and G, which have not got explored yet, C is the smallest vertex, so it started at 13 time. Now see the connection from C, it's B, E and F. B already got explored, E already got explored, but F has not got explored. So let's explore F at 14 time. From F the connections are E, which has already got explored, J it has also got explored, so we will not be able to go any further from F. So let us finish this at 16 time. Now F was explored from C. So we have seen all the connections from C, B, E and F. So let us finish this at 17 time. Some mistake is it will be 15 and this will be 16 time. Now once again there is no possibility of going to any other vertex from any of the vertex in this graph. So G is unexplored. So let us start G because this is the only vertex which is unexplored at this point of time. So this will be starting at 17. Let us see the connections from G. These are D and I. D has got explored, I has got explored. So we will not be going any further from G. Let's finish it at 18 time. So we have explored every vertex. Now see what is the exploration sequence. The starting time set at the vertices will be telling us the DFS sequence or the exploration sequence. So at 1 time A is explored. At 2 time B is explored. At 3 time E is explored. At 4 time J is explored. Fine. Then at 8 time D is explored. At 9 time I is explored. At 13 times C is explored. At 14 time F is explored. And at 17 time G is explored. So this actually is the DFS sequence. Fine, this is the DFS sequence. Now let us try to write the algorithm for the same. So in the DFS, what we are assuming that we have been given a graph, but no root is given here. In the DFS work, we are not assuming that any root is given to us. So for doing the DFS, we will have to set the color of every vertex. So for all U element of vertices of graph, do color of every vertex is set as white. Fine. Then what you're doing for all U element of vertices of graph, do if the color of U vertex is white, then explore this vertex. If the color of any vertex is white, then you explore this vertex and say the exploration is done with the help of DFS visit function. So you're going to visit the vertex using the DFS visit. Fine. So this is the algorithm for DFS. Yes, obviously we will be writing the DFS visit algorithm also. Now let us write the DFS visit algorithm. So a U vertex is given and we have to write the DFS visit algorithm for this. Now let us set some time here. Fine. So you can think of some time here in DFS algorithm only. Let us initialize the time to 0. And if we are at some vertex u, obviously its color will be white. So at the very first, let us make the color of this vertex u as gray. Fine, we've started seeing all the connections from u, so its color has been made to gray. Its start time is set. Whatever is the time, current time, one more than that is set as the start time of this vertex u. And then the current time is also updated by 1. Let's say the time is 0. So the start time will be set as 1 and the current time will also be set as 1. So that's why we are setting time equals to time plus 1. And now we will see all the connections from u. So for each v that is adjacent to u, do. For each of the vertex which is adjacent to you, you just do this. If the color of vertex v is white, if the adjacent vertex has a color white, then you call DFS visit, the same function, recursively with the vertex v. Fine. So this way every connection of u will be seen once. But the first vertex that you see, you will call the same function recursively. It means you are going in the depth of the first explored vertex. So the first explored vertex has a color white. You will pick that one only and you will explore that vertex. Now once you have seen every connection from u, then you will set the color of u vertex as black and finish time fu of that vertex as current time plus 1 while updating the current time as time equals to time plus 1. Fine. So this is the algorithm for DFS visit. So whichever vertex has to be explored, this will be explored using the DFS visit. So now suppose we have started from A. So the color of A is white. So we have called u. Means here u is A. Then the color of A will be set as gray and its start time will be set as 0 plus 1, 1. Current time will be set as 1. And then we will see all the connections from A. From A the connections are B and D. You see the connections are B and D. So we will first see B, and since the color of B is white, so we will explore that. It means color of B is white, so we will call the DFS visit with B, and now we will see the connections from B. So whichever first vertex we are picking, we are going in the depth of that. Once we see all the connections from A, its color will be set as black, its finish time will be set as current time plus 1, and the time will be set as, or the current time is set now as 1 more than the earlier time. The order in which the vertices are starting, it means the SU, which is the array. This will be telling us the order or the order of the exploration, means the time at which we have started the vertex will be telling us the DFS sequence. Fine. Now there is one more thing which is required to be done here. We need to set the predecessors. We need to set the predecessor of the vertices. For example, in this vertex, A has got started automatically. This was the first vertex. Okay, before predecessor, let me tell you one more thing, that we have started from A, then gone to B, from B to E, E to J. And then when there was no point of going anywhere else, we have come back to E, and then to B, and then to A, and from A we have gone to D. And then from D to we have gone to I. Now after going to I, we did not have any clue where to go next. Fine. So we thought of starting automatically this C, or out of C, F and G we have started from C, because C was appearing first in the alphabetical order out of C, F and G. So how we are ensuring that in the algorithm? Let's see the DFS algorithm. Here it says, for all U, that is element of vertices of graph 2, if the vertex color is white, then explore it. Now suppose A is explored, B is explored, C is not explored. So for each V means we are looking at the sequence of the vertices in alphabetical sequence, let's say. So A was explored, its color is white, done with that. B is explored, already explored, its color is not white. C's color is white, so we have started from C. So this loop is ensuring that. Fine. Okay, let's come back to this and let us set the predecessors here. So let's say the vertices are A, B, C, D, E, F, G, I and J. Sorry, let's do it here. Let's say we are setting up the predecessors here. Now A has got explored automatically, so its predecessor will be null. B has got explored from A, so B will have a predecessor A. E has got explored from B, so E will have a predecessor B. J has got explored from E, so J will have a predecessor E. Then we are coming back, J to E, E to B, B to A. Now from A we have explored D, so D will have a predecessor A. From D we have gone to I, so I will have a predecessor D. Fine. Now C has got explored automatically, so C will have a predecessor nil. Will be no predecessor. There will be no predecessor of C. From C we have gone to F, so F will have a predecessor C. Then G has got explored automatically, so its predecessor will be nil. Now here, if you see, if you reconstruct this graph again by only adding the vertices, and you see the predecessors, then what the predecessors say, there is no predecessor of A, B has a predecessor A, so A to B there will be an edge. So draw an edge A to B. Similarly, nil to C means C will have no predecessor. A to D there is an edge. B to E there is an edge. C to F there is an edge. G has no predecessor. D to I there is an edge. Then E to J there is an edge. Now if you see what outcome is there of this DFS, one of the tree is this one, CF. Another tree is this one, A to B, E to B to E, E to J, and then this one. So this is one of the tree. And there is one isolated vertex G, which can also be considered as a tree. So we have the collection of the trees. So this DFS is actually resulting us in a collection of the trees. And collection of tree is actually known as the forest. So outcome of this DFS is DFS forest also. The outcome of the BFS were the BFS tree. It was not a forest, it was a tree. And then the shortest path. and obviously the sequence of the vertices, the sequence in which I have explored the vertices. So here the DFS is resulting as the DFS sequence obviously, and the DFS forest as well. Fine. To ensure these things in the algorithm, we need to write, while initializing this graph, we will set the predecessor of each of the vertices as nil. Fine. And when we are visiting any vertex through the other vertex, for example, this V vertex is getting explored through U. So we will set predecessor of V as U. Thank you.